Welcome back. So, we're still working with our sequences. However, today we're moving on from arithmetic. We're going to consider something called geometric. Now, what geometric means is that instead of adding the same thing over and over and over again, we're talking about multiplying the same thing over and over and over again. So notice here, I multiply by 2 to get 4. I multiply by 2 to get 8. I multiply by 2 to get 15, or 16. My apologies. Over here, notice, you're not multiplying by the same thing to go from term to term. You're multiplying by different things, so that means it is not geometric. Now, one little tip that I want you to recognize. Sometimes with geometric, it's not that easy to tell what you're multiplying by. If you have some decimals you're multiplying by, again, not always easy. So what you can always do to check to see what you're multiplying by is take any any term, divide it by the previous term. So for example, here, 4 divided by 2 is how I can tell that that's multiplying by 2. 8 divided by 4 is how I can tell I'm multiplying by 2. 16 divided by 8 is how I can tell I'm multiplying by 2. So again, you can always do that. Take any term, divide it by its previous term, and that'll give you whatever you would be multiplying by. Again, just a little trick for ones that get a little bit harder. Now today, we're going to focus on recursive and explicit for these geometric sequences. Recursive works exactly the same way as it did for arithmetic. You have to state your first term. So in this case, my first term is 2. And then you have to state that for any previous term, the way to get to your next term is multiply by that common rate. Multiply by that 2. Okay? So again, recursive, usually really easy. Just state what the first term is and then state what you're doing. And in geometric, you're multiplying. So here I'm multiplying by 2. For the explicit formula, so this is the one again, in the end we're going to be using more often, and all you do is plug in the pieces. So for my explicit formula, I take my first term, which is 2, and I multiply it by the rate, which is also 2, to the n minus 1 power. Now the nice thing about geometric is you don't have to simplify it like you did arithmetic. Once you write the geometric explicit formula, you already have it. So again, nice thing is no simplification. One commonality to note though is notice you have that n minus 1. Okay, and again, you'll be given the formulas whenever you're given an assessment, but just a little trick to remember is you should be seeing the n minus 1 when you write your explicit formulas. And the neat thing is you can use the explicit formula to find any term in the sequence. So let's jump right in and start calculating some of these. So this first one, I think is pretty easy to see what I'm multiplying by. To go from term to term, I'm always multiplying by 2. So recursively, what this will look like is I state my first term and I state that for any term, I take the previous term and I'm going to multiply by 2. Okay, but you need both pieces just like you did with arithmetic. For the explicit formula, now I'm just plugging that into this. So again, just a little reminder of what that looked like. So explicit formula, my first term is 3 and my rate is 2 to the n minus 1 power. To calculate my 10th term, I plug in 10. Well, here, 10 minus 1. Before we go to type that into the calculator, I'm just going to go back and call that 9. Okay? So, 3 times 2 to the 9th power. So let's whip out a calculator. 3 times 2 to the 9th power. Oh, what did I type in wrong? There we go. 3 times 2 to the 9th power, 1,536. 1,536, and that's it. All right. For this next one, now this is one of those, it might be a little bit hard to see what we're multiplying by because you probably see that as dividing by 5. But this time, multiplication and division are not interchangeable like addition and subtraction are. So I can't just view this as dividing by 5. So what you need to do for me, what I need you to do is use that little trick. So remember that trick I said on the first page right here? Take any term and divide it by its previous term. That's what we're going to do. So I'm going to take 20 and I'm going to divide it by 100. So 20 divided by 100 gives me 0.2. Well, let's see if that holds true for all of them. So 4 divided by 20. I take a term and I divide it by its previous term. 0.8 divided by 4. I take a term, divide it by its previous term. So that means my rate, what I'm multiplying by, is that 0.2. So remember that method in order to determine what you're multiplying by. Because again, with decimals, it's often a lot more difficult to tell. So again, just take a term and divide it by its previous term. That'll give you what you're multiplying by. Recursively, I note my first term. Then I state I take any previous term and multiply it by 0.2 to get to my next term. Explicitly, an equals take my first term with my rate to the n minus 1 power. So that means to get my 8th term, I plug that into my calculator. Well, again, the nice thing is I know 8 minus 1. So I'm just going to call that what it is. That's going to be 7. So I can take this and plug this into my calculator. 100 times 0.2 to the 7th power, and that's going to be that 8th term, 0.00128. 0.00128, and I'm done with that problem. Now, kind of a neat thing I wanted to show you is look at this one. -2, 6, -18, 54. This is something we haven't seen yet. My signs are flip-flopping. So whenever my signs are flip-flopping, that must mean I'm multiplying by a negative. So here, if you note, I'm multiplying by a -3. Multiplying by a negative is how you can get your signs to flip-flop like that. So to get from term to term, this time that r is going to be a -3. So I state my first term. My first term is a -2. And now what am I doing? Well, to go from term to term, oh, I take my previous term and I'm multiplying it. Oh, not by -2. I'm sorry. And I'm multiplying it by -3. So that's how you can write your recursive one. Now, my explicit formula, I take that first term of -2, my rate of -3 to the n minus 1 power. So to get my 10th term, I plug in 10. Well, again, I know what 10 minus 1 is, so I'm just going to call that what it is, which is 9. Now I just have to type that into my calculator. So, -2 times -3 to the 9th power. And my answer, 39,366. 39,366. And that is it. So hopefully you notice the commonalities between what we did here and what we did with our arithmetic sequences. But do make sure you have all this written down. And if you still have any questions, please make sure you come and ask.